we've talked about velocity and acceleration for position vectors, but there's a special vector that's related to the velocity vector that we want to discuss, and that's this idea of a tangent vector. So if we can think of some sort of curve C that could be parameterized by a position vector r of t, then at any given point you should be able to find a vector that's tangent to the curve at that point. And if you remember, we would do tangent lines in the introductory calculus for scalar functions, but we find we can do it for vector valued functions. So how do we construct that? Well, in introductory calculus, we would do it by using the derivative, and we could find the tangent line at the point with the derivative. Now, we kind of do that already with a velocity vector, but what we'd like to do is come up with some sort of unit vector, t of t. And the reason why will become apparent as we move along, but it has a special value in the fact that we can always get a vector that has magnitude 1. So if we take some smooth curve and we define some sort of open interval I, and that's needed for a little more mathematical rigor, we can take that velocity vector at that moment. So, and we got the velocity vector as a function of time, but if we divide by the magnitude of the velocity vector, then we guarantee that we have a unit vector. Remember, any vector divided by its magnitude always is a unit vector. So assuming that the vector or the velocity vector is never 0, we can define this tangent vector, and that simply has that same behavior like the tangent line in introductory calculus. Now, I want to point out a very important piece of that, which is that the way the tangent vector points has to do with the orientation. So I could have two position functions, and they both describe circles. So the red one describes a radius 3 circle, and the second one describes a radius 5 circle. But the orientation is counterclockwise for the red circle and clockwise for the blue circle. So when we find the tangent at sort of that apex point, the tangent vector is pointed sort of in the direction of the orientation. So if I'm going clockwise, the tangent vector kind of goes in that direction. Counterclockwise, it goes in that direction. And we're going to compute some tangent vectors by using this formula in the next sections.